Hello, this is going to be our SI session for today. So I guess there are severe weather warnings, and so it was recommended to me to cancel the session for today. And so I thought, well, I always make my packets for you guys, and so um, I thought I would make a little video just going through the answers of the packet because that would sort of be the purpose of the SI session is going through the answers. So I want to make sure that you guys have the answers to these questions so that we can, just have them in the notes for the exam. Okay, so let's get started. Of course, I have this front page of the packet, and I recommend that you go through and look at all these things I write down. I don't put these here for no reason. The one big property to keep in mind that I will highlight always is this one. You definitely don't want to forget this idea. This may look complicated. This is just trying to convey the idea. If I have an exponent I don't really like in an equation, I can take a logarithm and undo it. And the same goes if I have a logarithm I don't really like, I can sort of I can put it over a base and undo it, right? That's sort of what this is conveying. Domain and range. The big thing here that we want to notice, because we're not really working with logarithms today, we're working with exponentials, is this range idea. This won't come up a whole ton. In fact, it might come up not at all. But what you do want to keep in mind is that an equation like this, oops, oh, that's not how you draw an x. Hold on. An equation like this is just not going to make sense, right? I can't really take an exponent and throw a negative on the other side of the equal sign. That's not really going to be a valid equation. So this would sort of not be true. That's one thing to keep in mind there. Then I listed properties of exponents and properties of logarithms. Again, we're not really working with logarithms today. I did give them to you just in case you want them, but we're more going to be concerned about our exponents. Make sure you're familiar with these rules. Not too bad. Multiplication and division multiplication and addition go hand in hand. Then division and subtraction go hand in hand, and then exponentiation goes in hand. I don't know. Just know them, please. And then again, we're not really going to be doing change of base with logarithms too much today. You may see me convert expressions in the natural base, because that's sort of, when we have an answer that's in the form of a logarithm, it can sort of be almost like tradition or just convenient to convert our answers in the natural base. But I don't know if it's required, but the big one we're going to be working with today is we will be seeing some change of base. I think so, at least. I don't know. I haven't really looked at these questions yet. Okay. Anyway. And then as for solving equations, right, there's no one-size-fits-all method. We're more just going to want to try and undo things where we can, try and isolate variables where we can. And hopefully after watching this video and doing the exercises, you'll sort of understand what I mean, and you'll have a better idea of what's going on. So yeah, I'm going to go through all the questions, but I do highly recommend, oh, sorry for the voice crack. I highly recommend that you try these on your own. If you haven't filled out the packet yet and you're watching this video, pause before I do the solution, try it on your own, see where you went wrong if you got it wrong, and sort of, and do what you gotta do. Just watching me do it is not going to help you as much as if you tried it on your own. Okay, first equation. We have 2 to the 4x equals 8. So let me just write this down over here. So I have a exponential with a 2, and then my x is caught inside that exponential. So I want to undo that somehow. And I want to undo that by taking the logarithm of the same base. So I do logarithm base 2 of 2 to the 4x. And then when we're solving an equation, I have to do the same thing to both sides to ensure that it stays equal. So that's an interesting G, but we take log base 2 of 8 like this, and then we can see what's going to happen from here. Well, based on that formula I highlighted on the last page, this base 2 and this base 2 sort of cancel each other, and we're left with 4x equals. Well, then log base 2 of 8 is actually going to be a number, right? And let's think about what this is trying to tell us. It's asking us 2 to what power? And I won't use x because we already used x. So use y. 2 to what power equals 8? And so I'm thinking, okay, 2 times itself, how many times gets me back 8? Well, 2 alone is just 2. 2 times 2 is 4, times 2 is 8. And so we have 3 2's, and so, 2 to the power of 3 is going to be 8. And so I can write down 4x equals 3. And then, of course, I'm just going to simplify this out and say that x equals 3/4. And I have the answers on my phone to make sure I didn't mess up. Yep, there we go. So that's going to be the correct answer. Okay. So let's keep going. Again, I recommend that you pause and try this next equation, but let's get into it now. So we get 5 to the 2x minus 1 equals 125. And so again, this is the same idea as last time. The variable I'm trying to solve for is stuck inside that exponential, and I want to undo that. And so I can undo that by taking the log base 5 onto both sides. And so now what we'll see is going to happen is this 5 and this 5 will sort of cancel each other out, and I get 2x minus 1 equals, and then again, well, what is this telling us? It's 5 to what power? I don't know, I just use y again is fine, equals 125. And so, okay, well, 5 alone is just 5. 5 times 5 is 25. Times 5 is 125. You can sort of think of that as like, this is 25. If I had 5 quarters, that's $1.25, right? However you want to think about it. 5 to the power of 3 is 125. So I can write a 3 in that spot right there. And then we're just going to solve this equation as normal, right? So I might want to add that 1 over. So I get 2x equals 4. Then I can divide that 2 over to get a final answer of x equals 2. I'm going to check my phone. And yeah, that is the correct answer. Okay. Let's go on to number 3. This is a typo. Hopefully it's kind of clear what I'm trying to ask here. I'm saying that 2 to the x cubed minus x equals 1. Sort of a little parenthesis mistake there. Again, we are just sticking to everything we've done so far. So I want to take the logarithm that's going to get those x's outside of that 2. So I take log base 2 of both sides. And now I may have discussed this in SI, but the log of any base of 1 is always going to be 0, because you can think of it like this. If I have any number, I don't know, 40 to the 0, that's going to be, looks like 40 degrees. That's going to be 1, 2 to the 0, that's going to be 1, e to the 0, that's going to be 1. So, any number we put in, any number raised to 0 is 1. So log of any base at 1 is always 0. And so what will happen, this will cancel, and then this thing over here goes to 0. So our new equation will look like x cubed minus x equals 0. Now, we want to be a little careful when solving this, because I know it's been, a million years since we've done polynomials, but this is a polynomial. So we will factor out an x, and then we will factor this expression right here into this. And we have this whole thing equaling 0. And so now I want to ask myself, okay, well, what values of x get me 0? Well, x can be 0, x can be 1, and x can be -1. And so those are all the valid values of x that let that equation be 0. And in turn, that is the same values of x that would make this expression true. And so our final answer is that x equals, I think, looking at your exam too, I think they ask you to write solutions as sets a lot. So let's write a set. I could open this with some curly braces. I could call it 0, -1, 1. Close it off with some curly braces. So there you go. That's a solution set for number 3. Sorry if I don't exactly solve this as smoothly. There's a guy talking in the next room over so loudly. I can hear literally every word he's saying. I don't know if he's screaming at the wall or something, but anyway, okay. So we get 3 to the 2x equals 5. And so again, hopefully we're more used to this pattern now. But what we can do here is we can actually undo our 3 with a log base 3. And then from this point, we can see that our 3's will cancel. And now here's where we sort of get into something we may not be used to. And I tried to leave a footnote, but I accidentally left it on the next page. So you can see this little 1, that means a footnote. So I have something listed at the bottom of the page all the way down here. But I guess we'll just read it now. So keep in mind that a logarithmic, keep in mind that a logarithmic expression that does not contain a variable is a single definable number. An answer like ln3 is perfectly acceptable as long as there are no variables involved. So what this is saying is that we can write answers that just are a logarithm, and that's a valid answer. And you'll see that with this one, right? So in all the previous questions, when we got to the point where it was like, what did we have? We had, like say, 5 to the power of 3 was 125, or a log base of 125. We can solve all those logarithms very easily. We cannot solve so easily the log base 3 of 5. And we're actually going to leave that just as the log base 3 of 5, right? So we're really not going to touch that. And so we're going to continue in solving, and I'm going to divide out that 2, and we're left with this. And what you'll notice is that I've completely isolated the x, right? So the left side of the equation says x equals, and then I have a completely no variables involved expression that just has logarithms in it, right? And so if I wanted to like write down the answer in a decimal, it'd have an infinite number of decimals. That's kind of why we leave it in this form. Now, the one common thing you'll see is it's very common to convert to the natural base. And so we're going to use that change of base formula as before. So we can think about this as not 2, I'm sorry. We can think about this as, oh boy, I dropped my pencil. We can think about this as 1 over 2 times log base 3 of 5. Now, if I want to convert this to the natural base, what we do is we take the logarithm, we choose our base, so natural base, like at ln, and then we have the thing inside the parentheses divided by the old base. So this is how we convert to natural base. Again, if you're a little confused on that, check that formula I wrote down for change of base on the first page of the packet. But then I can just sort of put this back into here, and what I will get is natural log of 5 times 2 natural log of 3. And so that will actually be a just as equivalent to this final answer, but it is very common to leave things in natural base. And there is a chance that on your tests, you might be asked to convert expressions into the natural base. So, I don't really know what's going to happen, but that's totally possible. Okay, let's move on. So again, we're going to see it. Oh, hold on. Oh my, this is another, okay, here's my typo, right? I had the same equation twice. Yeah, I had a very busy day today. So anyway, apologies for that mistake. This is the same as question 4, so we already know the answer to that one. So we can go ahead and move on. Let's do this one. So we're actually not going to start by I just turned my tablet off. We're actually not going to start from the exponent this time. We're not going to immediately jump with a logarithm. I can see that I have some stuff I can take care of first. Minus e to the 2x equals 250. And so I'm actually going to start by dividing 500 by everything. And so on, not 6, on the one side, the 500 just goes away. And then I get 250 over 500, which will simplify to 1/2. Then what I will do is, so I don't want to skip steps here, but as you can see, I will add an e to the 2x, and then I'm going to subtract off that 1/2, and then 1 minus 1/2 will just be 1/2 equals e to the 2x. So hopefully that's pretty clear what happened there. then I do want to undo this e to the x now. So I'm going to take the natural log of both sides. So I get natural log of 1/2 equals the natural log of e to the 2x. Now that e and that natural log will cancel, and we're left with the natural log of 1/2 equals 2x. Now, let's sort of be careful with what we want to do here. So this is going to be interesting. Let's see, how can I take care of this? So before we do anything, let me show you what's going to happen on the left side of this equation. I'm going to leave 2x as 2x right now. Notice that the natural log of 1/2 is going to be equal to the natural log of 1 minus the natural log of 2. And so notice from the previous question we went over, or the last two or something, the natural log of 1 is going to be 0. So this is also equal to 0 minus the natural log of 2. So instead of having natural log of 1/2 on the left side of the equation, we're actually going to put natural log of 2 on the equation. So what we have instead is that the negative natural log of 2 equals 2x. Now I will divide over that 2, so my equation is a little extra simplified. We get negative 1/2 log of 2 equals x. So, I was trying to sort of explain what's going on here. Didn't want to jump straight to saying ln of 2, but hopefully you can sort of see how I took the natural log of 1/2 and then converted that into negative natural log of 2 using the properties of logarithms. Okay. Next question. So we have e to the 2x equals 2e to the x. Let's see what we're going to want to do here. Oh boy, I got a yawn. All right. What do we want to do first? Let's just try and do a natural log on both sides, right? So we get e to the 2x equals 2e to the x. And let's just take the natural log of both sides and see what happens, right? Some of these questions I haven't seen in a while, so let's do this. That's supposed to be an x. And what we'll notice, this side cancels. We're left with 2x. I can actually expand the right side using a logarithm property. So I can say that log of 2 plus ln ex. Okay, so yeah, I can see where this is going, right? Because now natural log and e cancel. This gets us 2x equals natural log of 2 plus x. And then I'm just going to subtract x from both sides. And I get x equals the natural log of 2. Yeah, that was pretty easy. Right, so yeah, some, equation looked a little interesting, but we just attack it with a natural log and we end up with the right answer, right? Okay. All right. So let's do number 8 now. My warning for this one, I have a bit of an unusual way of solving it. I will completely admit. The book has what I'm assuming a different way of solving this from how I do it. I'm guessing it's a change of base problem, and it has a different expressing way to say it. Here's my only thing. I'm gonna put like a little star next to number 8. Don't listen to me. Don't, I when I solved this for last year's semester, someone said they could smell the alcohol coming off of the solution. I mean, that's for sure. Like, what you're about to see, hide your children. It's going to be very graphic how I will solve this. Okay. So we get, that's an ugly 7. We get 7 to the 3 plus 7x equals 3 to the 4 minus 2x. Now here's what I'm going to do. I'm going to almost like simplify or expand these exponents using properties of exponents. So I'm going to turn this into 7 to the 3rd times 7 to the 7x equals, and then this will be 3 to the 4th over 3 to the 2x. Now here's what I'm going to do. I'm going to move all the terms that contain an x to one side, and all the terms that don't contain an x to the other side. So I will multiply by 3 to the 2x on both sides. And I will also be dividing by 7 to the third on both sides. And what this will get me is 7 to the 7x times 3 to the 2x equals 3 to the fourth over 7 to the third. So hopefully you can sort of see how I'm just sort of cross multiplying / just like moving things around, right? I haven't really done anything significant here. This is where it's going to get very ugly very fast. I am going to factor out a power of x from the left side. So I'm going to take this x here and this x here and pull it out using properties of exponents. And so what I get is I get 7 to the 7th times 3 to the 2 to the power of x equals 3 to the 4th over 7 to the 3rd. This is an absolutely disgusting move. I don't recommend you do this. This is horrible. I don't know what I was thinking when I did this. This is rated R segment of the video. Close your eyes if you're queasy. Absolutely horrible that I'm doing this. Keep in mind that a logarithm can have any base we want, as long as that base is positive, more specifically non-zero. And so what I'm going to do is I'm going to pick the logarithm of a base that will get me back my x. I want to get x out of there. And so what I'm going to do is, of both sides, I'm going to take the logarithm of the base 7 to the 7th, 3 to the 2nd. There's a valid base I can take. I'm going to take that logarithm of both sides. I guess technically this should have a bigger set of parentheses. I'm taking that logarithm of both sides. And what I get, 7 to the 3rd, is that this and this cancel, and we're left with x equals all of that junk, which I'm not going to write out yet. Right, that is an absolutely disgusting move. Horrible of me to do that, right? I should be shunned. I should be, my wanted poster will be in Morton tomorrow or whatever. And so, technically speaking, this answer is a closed answer. I can put that in a calculator and it will give me a decimal that is accurate. But let's make this a little easier to read because this looks horrible. So what we will start is, let's start by doing the change of base formula. So I want to get this into not a disgusting looking base. And so we're going to use change of base by, remember, I take the natural log and I take what was in my parentheses, and that's 3 to the 4th over 7 to the 3rd. Then I divide that by the natural log of what my base was, 7 to the 7th times 3 to the 2nd. Now I can pull apart these natural logs using properties of logarithms. And so what I will get is the final simplified answer of natural log of 3 to the 4th minus natural log of 7 to the 3rd over natural log of 7 to the 7th minus natural log of 3 to the 2nd. I actually lied. That's not the simplified answer. We can take this a step further by bringing down the exponents. So the final answer is 4 natural log 3 minus 3 natural log 7 over, and let me just sort of like draw a line to separate this, 7 natural log 7 minus 2 natural log 3. That is all equal to x, and that's a much easier answer to read. So yeah, bit of an evil question for me to ask, I admit, but that was my solution. I'm sure there's a way better one out there. You can just find it for yourself. All right, next question. Oh, this is a good one. Very, very good method to know. So we have 2 e to the x's, and one of the e to the x's has a 2 in front of it. And so this is usually our hint. I have to yawn, but this is usually our hint to use u substitution. So if I rewrite this, right, if I write this out, e to the 2x equals e to the x plus 6. If I rewrite this, I can use properties of exponents to notice that this is e to the x squared plus, or equals e to the x plus 6. And so what I have here is I have a quadratic that just looks really funny. And so what I'm going to do a substitution. So I'm going to take u, and I'm going to set that equal to e to the x. And now I'm going to put that back into my equation. And what I have now is I have u squared equals u plus 6. And now this is just a quadratic that hopefully we can all solve, right? So if I subtract my terms over, I get 0. I can factor this into probably minus 3 plus 2, right? Is that right? Yeah, it looks correct. This is set equal to 0. And so I know that u equals 3 and u equals negative 2. But remember, we want to, now that I've isolated u, I want to bring that back in to e to the x, right? And so what we get now is I get that this tells us that e to the x equals 3 and e to the x equals negative 2. And if you remember all the way back at the start of the video, I mentioned how this doesn't make sense, right? It's not a valid, I can't have an exponential equaling a negative. It was actually incorrect, and our only valid answer is e to the x equals 3, right? Because I can't have a negative as an exponent. Okay. This next question, if you want another shot at u substitution, it's also a really good example, so I recommend you pause and try. But again, I'm yawning a lot, but same idea holds. I can notice that 4 is actually equal to 2 to the 2. Right? And if I use properties of exponents, and let me try and do this in a other area. Hold on, let me erase this. Let's just deal with 4 to the x right now. That is 2 to the 2 to the x. I'm going to use that property of exponents to say that this is 2 to the 2x. And then I'm going to reverse that property and say this is 2x to the power of 2. All right, so sort of notice how this is still just the same thing as 4 to the x, right? And so if I rewrite this, well, we get 2x to the 2 plus 2x equals 12. U substitution again. I say that u is 2x, and we get this. And again, this is just a quadratic, so I get u to the 2 plus u minus 12 equals 0. What will this factor into? Was going to be plus 4 minus 3, so we should get u plus 4, u minus 3 equals 0. And then we get that u equals negative 4, u equals positive 3. And again, if I put my u back in, or my x back in, 2 to the x equals negative 4, 2 to the x equals positive 3. This is not a valid solution. Take the natural log of both sides. X equals the natural log, or sorry, not the natural log. Who am I kidding? X equals log base 2 of 3. And if I really want to convert that to natural base, I can say that x equals natural log of 3 over natural log of 2. And that's our final answer. Okay, and then the last two questions are more quote-unquote normal, I guess. Find the domain of both these things. So the first one, I guess is a trick question if we want to consider it that. Really, I'm just thinking, right, okay, what's the only thing that could break my domain? If anything in the denominator ever equals 0, well, keep in mind that e to the x, as well as e to the negative x, they have a domain, a range of 0 to infinity. So neither of those expressions can ever actually be 0, and they can't be negative either. And I'm adding them together. So I have two numbers that no matter what I put in, I'm always getting a positive, and I'm always adding them. So I can never get 0, or I can never get a negative and a positive to cancel out. So I'm actually never going to have any scenario in which this denominator is equal to 0. And so the domain of this is, all real numbers, or if you want to write the bold R, either one of these will work. So the domain is all real numbers. Everything works here. As for the last problem, this one will be, well, we're going to use the idea that if I want to I guess this is more logarithm stuff, but I'm going to take what's inside my parentheses and set that strictly greater than 0. And so I get this situation. And then we can just sort of solve this for x directly, right? I have no problem with adding over an e to the x. And then I can just take the natural log of both sides. And so I want to interpret this into interval notation. And again, this is sort of getting used to the idea that natural log of e is just a number. So I can write out this interval as just negative infinity up to natural log of 3. And then that is the domain of that problem. So, yeah. I mean, that's all I have for today. Sorry if I'm a bit of a awkward video maker. I'm more used to doing this in front of a chalkboard, not a computer screen. But hopefully this was helpful. I guess if anything was super confusing, you can send me an email. But I think almost all of these problems come directly from the book, so they should all be in the book as well. And of course, um, you know, I don't know, ask a friend or something. All right. Well, besides that, take care, stay safe in the tornado or whatever, and I'll see you guys on Thursday.